Hello again, you sick, twisted weather freaks. Welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. It's March 10, 2013. It's 11 p.m. My son is 16 years old, and I'm an intellectual powerhouse and all-around fantasy baseball pervert. I'm your host, meteorologist DT from weatherwist.com. We time to talk about weather across the USA, and especially over the eastern half of the next 2 weeks. Now, in this particular edition, we'll be talking about the second half of the winter, how the forecast that I believed has worked out pretty well, that the second half of the winter was going to turn out significantly more active than the first half, the blocking pattern, which is set up here for March 2013, and then two possible events, one March 17, 18, one March 20th. So let's get to work here and see what's going on. Let's talk about the second half of the winter and how it's worked out. Now, back in my winter forecast, I was talking about the use of analogs and whether or not the analog was which analog is the correct thing to do. And this is actually from the winter forecast, and that's online on the website. But you can see that I'm talking about here the correct parameters, and you have to pick the right one. For example, if you pick focus on El Nino winters, when we have a La Nina, obviously your analog for the winter or the summer is not going to work out. And let's look at this past summer. It was assumed by most seasonal forecasters, including myself, last summer 2012, El Nino was going to show up, and that's why the hurricane season was initially forecasted to be below normal, and some sort of warmer but wetter pattern would kick in over the plains and Midwest. But as we know, the El Nino pattern never developed. So picking the right parameters when you're picking an analog to get an idea what the seasonal forecast is going to look like is very important. And I made the point here about the QBO, which is the quasi-biennial oscillation. Now, that's a mouthful, and of course I use that term, but it's a really powerful and I think it's an important forecast tool. And but it's important that it's not oversold. I mean, it's not a be-all, end-all. But in this particular instance, I saw something significant happening with the QBO. In case you don't know what this is, the QBO is a level of high wind which exists at the very, very top of the atmosphere, really above the jet stream, almost at the edge of outer space. And it oscillates back and forth from east to west along the equator. And it goes through cycles, so it may reach a negative value, very strong, which when it's coming from the east, and then it'll go to neutral, then go to the positive value, and then back down like a sine wave, up and down and up and down. And this movement has implications for the patterns during the winter and the summer months. So the argument that I was making here was I was looked at the analog years for the QBO. Now what you're looking at here on this slide is all of the QBOs from January of 2012. You follow me? Now look what happened. It reaches peak here. Let me point this out so you can see this. It reaches peak here in August of 2012 at minus 27. But it's also very strong here, and very strong here, and very strong here. So I was looking at all the QBOs which featured very strong negative values of minus 25 or lower during the summer, early autumn months. And even in October, it was very strong from almost minus 25. So what I was looking at was all those years and what those Decembers and winters look like. But then I suggested, I was wondering, what happens if the QBO rapidly rises? What happens if it breaks down? And that's what I was concerned about. And in fact, we saw this happening. After October happened, we could see, let me change the color here so you can see it a little better. Yeah, we'll use this color here. And you can see that it began to rise rapidly here. This is, plus 6, the change here. And then in December, it was minus 10. That's a pretty big change from the last 2 months. That's a rise of 14 points. You see that? And then January was minus 6 and then minus 1. Now, the reason why this is important is because my winter forecast operated on the premise I've discovered, and some other people have as well, that when the QBO during the winter months is between, let's say, minus 8 and plus 8 around the neutral area, you get a lot more blocking patterns in the northern latitudes. And that's what that's what my forecast was based upon. So I was arguing there's a high probability that October was going to be minus 20 to 25, November minus 15 to 20. But again, I was assuming that. But the argument was that February and March and January, the QBO would rise, that is to say, move northward towards the zero level. And I was looking at winters where you had a strong native QBO that rose towards zero in the second half of the winter. And I came up with these particular analogs right here. And if you looked at all those maps of those analogs, jet stream patterns, you saw this. In December, we saw a mild pattern with the polar vortex situated up in the northern latitudes over Alaska, as we can see up in here, and then a ridge right in here. And this would make, of course, a very warm. All the cold air is back in here. That's pretty much what we saw. And then this was December of 2012. And what did we saw? Again, same general pattern here. So this worked out nicely. Here is our trough over the west coast, ridging over here, but the deep trough on the west coast was supporting a warm pattern in the eastern United States, and that's pretty much what we saw. So that worked out nicely. Then in January, in my analog years, I saw a huge shift towards a blocking pattern developing over the northern latitudes, and a persistent trough over Newfoundland and the northeastern United States. And if we look at the overall, you can see that. There's our trough right in here. You see it in here. You point it out so you can see it. See that big negative area? So that's the blocking was over here, and the negative trough was there. And if we looked at in fact, January 2013, what did we see? Well, we saw some blocking develop in here. We still had a ridge over the southeastern United States. But remember, January was a variable month. The second half of the month of January 2013 turned out to be much colder than the first half. And then in February, we saw this pattern developing here. We saw a large amount of blocking developing over here over Greenland and eastern Canada, and then a persistent negative anomaly here over the eastern United States. So that worked out pretty well as well so far. And this was the I thought was going to happen in February. This was the analog we were looking at. And again, we could see some blocking here in eastern Canada and a trough over the western U.S., generally below normal heights. So that wasn't a bad match. That was a pretty close match. It wasn't a perfect match, but it wasn't bad. And so if you looked at January and February, we combined, we saw a huge increase in the blocking pattern over here, over Greenland and northeastern Canada. So overall, the analog worked out pretty well. And then we saw a significant shift, and I think that forecast for a colder and stormier second half of the winter has worked out pretty nicely. And we have all of March to go through yet. Now, this is the forecast for the cold front coming up here on Tuesday. And we can see very nicely that this is the GFS here from the 12Z run. There's the cold front going right through here. You can see it. And there's our line of showers and storms. Now, it comes through early on Tuesday morning around 7, 8 a.m. So we're probably not going to see a lot of thunderstorms with it. If the front is delayed, we would see more. This is the NAN, which is a little slow with the front, which I think makes more sense. I would not bring the front through till midday on Tuesday, but that's a possibility either way. So this is the overall pattern of the European model here from Sunday morning. And what's important to notice here is this is the hemispheric shot. Is all the negative, all the cold air, the below normal heights is over on the Asian side of the world. This is we split the world in half. This is the Asian side, and this is the North American side. And we can see that all the very huge below normal areas are in this area. See all these negative numbers in here? That represents a really, really Arctic air. And most of Canada over the United States is not, at least not initially. So we're going to talk about this blocking pattern developing in March 2013. If we look at all the teleconnections, we can see this is the Arctic Oscillation right in here. The Arctic Oscillation drops here in the middle of March, goes to negative again. This here is the eastern-based NAO, which is slightly negative, not very much, only a little bit in here. But if we look at the western-based NAO, it's the whole value is quite negative. This is just all of it. You can see reaching a peak right down in here. This is when we might get our storm on the East Coast, right here on the 20th. So that's interesting. This is the PNA, which goes back and forth, and this is a split because the GFS and the European have very different solutions about what's going to happen with the PNA. And this is the western-based NAO. When this thing just tanks, this is when it's over by Greenland. Look at this thing go boom right in here. This is very low values. Look at those numbers, minus 400, minus 450. Wow. Those are very, very strong negative western NAO values. So let's talk about March 17th and March 18th. Well, this is, we have two possibilities here. Now, this is from early on Sunday morning. And what the European was doing in particular, and the GFS was doing this as well, so it wasn't just the European. We had the front like this, and here's our Arctic high. Now, this is all way cold in here. Now, this is low-level cold air. This is all too warm for snow, but it might be cold enough for ice. And the low moves here. The cold air comes a little further south, so we're looking at ice going over to snow. Not a huge event. This is not a big low-pressure system, but this is what the model is showing this morning. And if we look at the day 9 European from early on Sunday morning, we can see 4 distinct centers developing, and this is showing a nice equal pattern developing. We're seeing some stability here. We see one center of below normal heights here, another one over Europe and Scandinavia, another one over southeastern Canada and the northeastern U.S., and another one in the Gulf of Alaska. So this is what we call a four-wave pattern. It sets up four waves. 1, 2, 3, 4. And that's a stable pattern if it sets up. Now this was the European from early Sunday morning. Now after that wave moved through, the European for early Sunday morning was showing that the trough was going to move off the east coast right here. There's the trough. It goes out to sea, and we have this big warm-up developing here. Look at these amazing warm temperatures over the plain states. It's probably going to reach 90 a couple times here in the 6 to 10 day over the plain states. It's definitely going to do that here this week, but it'll probably get next week over much of the central and lower plains because of the way the pattern's shaping up. A trough here and a trough here, but that means this whole area stays very warm. And that's a pretty impressive looking pattern for early spring, also fed by the drought over the lower plains and the central plains as well. Now let's talk about March 20th. Now this is the new GFS, this is the 12Z run, so let's take a look and make sure we point this out. This is the 12Z run in here, you see it? Okay, now this is the disturbance here. What's happening is this trough is coming down this way, and that forces the atmosphere to pop a ridge here. You see that? Comes down. This response going up. That takes a piece of energy here and it drives it towards the east coast. But here's a blocking pattern. So it has to go underneath it and we get our possible storm. And if we look at the surface map, this is what it looks like. Now, initially, this is all too warm for snow. This is not a snow pattern initially. This is all rain in this whole area in here. So that's what this is. This is all rain in here. But up in here, it's cold enough for snow. And the cold air is coming southward. At least that's what the European is showing. Here's the storm bombing out at day 9. That's just a monster storm. Here's a blocking pattern. There's our strong ridge on the west coast. A very powerful system. That's what the storm looks like. You can see this is rain all up and down the east coast here, at least from Atlantic City. This is an east wind. You see the high is way to the north, so this is an east wind. And maybe western Virginia, the Appalachians, the Shenandoah Valley could see a big snowstorm out of this. Eastern Tennessee, western North Carolina, West Virginia could get really hammered. But in Richmond, this is rain. North Carolina, it's rain. Delmarva, it's rain. But once it moves off the coast, it's a different matter. Now here the big low is moving off the coast. We can see it very clearly. And there's our big storm moving off the coast. Now everybody's gone over to snow. But now look at this. The rain-snow line is pushed way up into New England. Boston's rain, New York City's rain, Philly's rain, D.C.'s rain again. And it's all snow back up in here. Gee, that looks awfully familiar. Yes, I think it does. Yes, March 6th. Yes, I think so. Anyway, that's just one possibility. Now, this is the European ensembles, and what the ensembles are showing here is there's our negative NAO. You can see the huge positive anomaly up here. That's a negative NAO, Arctic oscillation. There's the negative AO, and we have a three-wave pattern developing here. And again, because the trough is coming in this way, we're getting a ridge rising here, and this disturbance right in here, that's the situation which might cause the East Coast storm to develop. That's the feature. This is day 9. We can see the same feature. There's our negative oscillation in here, and there's the N negative NAO, the Greenland block, and there's the piece of energy right there coming through the East Coast. So the ensembles are pretty supportive of the overall pattern. Now the ensembles have the storm further north, so that would be good for New England and the Northeast. And for a more north track would mean colder temperatures for them and potentially more snow. But if you look at the split here, the European and the GFS do not agree. Look, they both agree on this feature right here. They both have it. See it? Let me change my markers here. They both have this feature, and they both have this feature. See it? There and there. And they both have the block. But what they don't agree is this whole pattern here. They completely disagree with this. GFS is a big trough in this area, and that pops a ridge, and that European does not have that at all. So they don't agree. So there's not a lot of agreement here. These are the GFS ensembles. If you look at the individual members, none of them have an East Coast storm. None. Zero. None of them have an East Coast storm. Not a single one of them. They all have this persistent trough in the east, on the west coast right here, and a ridge in this area. So it could be right. I'm not saying it's wrong. That's just showing the difference. And if you go further out in time, this is the week 3 or 4 forecast. Very cold, a lot of blocking up in here. You can see the high level blocking up in here. And a trough over the eastern United States or just off the east coast, week 3, week 4. This takes us to early April. Very persistent blocking pattern. So, in summary, the super plains looks pretty warm for the next 2 weeks. The pattern favors some sort of big event on the east coast. Could be inland, could be off the coast, don't know yet. But as long as the blocking pattern remains in place, March looks below normal or much below normal for most of the, in terms of temperatures, for most of the eastern half of the country. This is meteorologist DET. I'll talk to you soon.